Hi everyone, welcome back. Let's go ahead and take a look at some of the implementations of what we have talked about in the previous videos. In this particular video, we're going to be taking a look at your port types. So we're going to be creating access ports. We'll be taking a look at your trunk ports. We'll create VLANs. We'll do VLANs manually without VTP, and we'll do it based on VTP as well. All right, that's what this particular video is all about. So you get a chance to see the actual implementations of these technologies that we have discussed in the previous videos. So as I said, creating VLANs and assigning ports to VLANs, that's the access portion of it. The access ports over here. Trunking between the switches. And then once we're done with that, I'll also show you how to do the same thing with VTP to propagate VLANs across from one switch to another. We'll set up one as a server, the other one as a client. To do this, the topology that I'm going to be taking a look at is this. This is your physical network diagram in which I have two switches, switch 1 and switch 2. On the two switches, I have two VLANs, each one having two. I have VLAN 10. In this example, I just have one port in VLAN 10 on switch 1, which is gig 01, and the other port for VLAN 10 is on switch 2. So if I want these two to talk to each other, they need to traverse from one switch to the other, keeping the VLAN tag in place. And that's where the trunk port comes in between switch 1 and switch 2. All right. Similarly, I have another VLAN over here, which is gig 03 of the two ports, switch 2, PC2 and PC4, PC2 connected to switch 1, PC4 connected to switch 2. I want them to talk to each other, again, going over the trunk. Okie doke. So that's what my objective of the lab is. Now, one thing that you need to understand, this is your physical topology. This is how the cables are connecting the different PCs to each other. The other thing that you also need to keep in mind is the logical topology. Although you see it like that, logically speaking, I have two VLANs that do not have the ability to talk to each other right now because there's no router involved. So in my topology over here, I have PC1, which is 192.168.1.51/24. On the same network, I have PC3. You don't see the switches in this layer 3 or logical diagram. This is the 192. If you take a look at your subnet, 192.168.1.0. And I have another VLAN over here. This is again a logical depiction of it, which also has two PCs in it, PC2 and has PC4. PC2 192.168.2.52 and PC4 has an IP address of 192.168.2.54/24. So these guys are both on the same network, the green VLAN. One VLAN corresponds to one IP subnet in most cases. So this is what it looks like right now. So PC1 and PC2 or PC3, PC4, they cannot talk to each other because they're on two different subnets. I will be doing that in the next set of labs, next topic, which is inter-VLAN routing, where I will have a router that connects the two IP subnets to each other. But at this point, my objective is not to communicate between the VLANs, but within the VLANs. All right, that's something that I want to make sure you guys understand. And by the way, this diagram that I showed you over here is known as your layer 3 diagram. The one that I showed you was your physical diagram. This is also called your logical topology. All right, versus what you see over here is your physical topology. Physical topology is just the way the cables are laid out, but the controlling element is the logical topology. So for example, although PC1 and PC2 are on the same switch, they will not be able to talk to each other because they're on two different VLANs, and that's where the logical topology comes in. That's the one that controls it. So how do I go about doing it? How do I set this up? There's different steps that I follow to do that. The first step is I will create the VLANs on the two devices, the two switches. I need two VLANs on each, VLAN 10 and VLAN 20. Although all I got to do is give it the VLAN ID, which is a number. As I said, between 1 through 4094. There's some reserved VLANs over there as well. Once I create it on switch 1, I need to do the same thing on switch 2. These are independent switches to do that. Okay, so how do I go about doing it? Let's take a look. I'll show you the required, and I'll also talk about what is something that you might want to do as an option. So the way you create a VLAN is by using the VLAN command. I can create VLANs by specifying a single VLAN like this and give it a name. So VLAN name, let's take a look at what my requirement was. I'll do it based on the requirement. Configure the VLANs required on the two switches. This is done by using the VLAN command under the global config mode. Option, you can also assign them names. Names, it's up to you. I'll call them red and green. They don't need to match on the two devices as long as the number matches. Okay, but in my case I want to keep it the same, so I'll say name red. That's just optional. And VLAN 20, name green. The name is not important. Now once I'm done with that, I can actually see this. Oops. There you go. VLAN 10 and VLAN 20 with the names specified over here. Name, as I said, is not that important. What is important is the number. So switch 2, I need to create the same VLANs over here. So VLAN 10. Now one more thing I'll show you. If I want to create multiple VLANs at the same time, I also have the ability to club them up. So you can say VLAN 10 and 20, create them, and then now if I take a look at my VLANs, I would have the VLANs created. All right, but the names of VLAN 0010, 0020, I can go back into it to match the other side. I can do VLAN 10, name red, and VLAN 20, name green, so that they match. It really doesn't matter as long as the ID matches. That's all I care about. All right, just want to make sure you guys are on the same page with that. So two different ways of creating the VLANs. What are those two different ways? I can either individually go inside my switch and say VLAN 10 and VLAN 20. Creates the two VLANs. This puts you into a subconfig mode where you can give it a name. All right. As I said, name not that relevant. Or the other way to do it, if you just care about the number, VLAN 10 and 20, it would create that for you right off the bat. And then it uses this format for the VLAN name, the default VLAN name. VLAN, the word VLAN, 00, and then XX, which would be the VLAN ID. All right. So my VLANs are created on both the devices right now. That's my first step, create the VLANs. Now, once I do that, the next thing to do is assign the ports to the VLANs. What is that? Now, if you take a look at your logical topology or your physical topology, you'll notice that I need this port on switch 1 to be part of VLAN 10. It by default will be part of the default VLAN, VLAN 1, and I want switch 2, gig 01 also to be part of VLAN 10 so that they can talk to each other. And in order for them to talk to each other, I would need to create a trunk on gig 00 on switch 1, gig 00 on switch 2, so that I will be able to cross the traffic for VLANs 10 and 20 that I've created over here. All right. So how do I create an access port? We've also looked at that in the lecture video, but let's do that over here. So as I can see from my physical diagram, I need switch 1, gig 01 to be part of VLAN 10, switch 2, gig 01 to be part of VLAN 10. That's what I'm going to do over here. On switch 1 first, interface gig 0/1, switch port, mode access, make it into an access port, switch port access VLAN 10. Now if I do a show VLAN command over here, you will notice that this port, this VLAN 10 now has one port in it, and that is gig 01. By default, all the ports belong to this default VLAN 1. gig 00, gig 02, 3, 10, 11, 1213. All the ports that are connected to this particular switch. This is an 8-port switch that I have. And I'll do the same thing on switch 2 for VLAN 10. So over here, gig 01, switch port, mode access, switch port, access VLAN 10. Done. So at this point, if I want, I can check to verify. Oh, actually, I can't right now because I don't have a trunk. So let's go ahead and assign the VLANs and then we'll do the trunk. So this part is done. My first VLAN, VLAN 10, is configured. The next thing is gig 03, which is the port connected to PC2. Gig 03 on switch 2 is connected to 4. So these two ports, gig 3 of switch 1 in gig 3 of switch 2, should be in VLAN 20. So how do I go about doing it? We'll do a before and after. You do show VLAN right now. Gig 03 right now belongs to VLAN 1. I need it to be part of VLAN 20. How do I do it? Let's do this first. Again, same thing over here. Gig 03 is part of VLAN 1. I want it to be part of 20. And again, same way, gig 03, go into the interface, switch port mode access, switch port access VLAN 20. Show VLAN is the command to verify the membership, and there you go. This port now is part of VLAN 20. And I'll do the same thing on switch 2. Good. So that is how you assign a port to a VLAN. So that's how I've created the topology where I have PC1, PC3, PC2, and PC4 in different VLANs. Once this is done, the last step is to create the trunk between them. What's a trunk? That's gig 00 on switch 1 to 2, so that the trunk can carry traffic for what? VLAN 10 and 20 across to the other side, maintaining the VLAN tag. So the VLAN tag, when it goes from switch 1 to switch 2, it is carried across in that particular frame. And that's my objective over here. So if you take a look at it, let's create the trunk. All the ports in VLAN 10 on switch 1 can communicate to each other. All the ports on VLAN 10 on switch 2 can communicate to each other. The same holds good for VLAN 20 on both switches. In my case, I don't have that. I just have one PC per switch. So, but if I had 4 or 5 different devices over here, let's say I had another, we'll put it in red, another PC over here in red, another PC over here in red, and I've assigned these ports to what? All these ports to VLAN 10, they would be able to talk to each other. But they would not be able to talk to PC3 yet because the trunk has not been established between switch 1 and switch 2. So now we need them to talk to each other. This is done by creating a trunk between the two switches so that the VLAN tag information is carried from switch 1 to switch 2. And how do I create the trunk? Let's go ahead and take a look at that. To create the trunk, 2 commands. Number 1, you need to specify your encapsulation. As I had told you during the video for the port types, the 2-type encapsulation, the Cisco proprietary one, which is not very common, and even on Cisco switches this is getting phased out, which is ISL. This is Cisco proprietary. Open standard is .1Q. All right, good. So in my case, I'm going to use .1Q. I'm going to create the trunk between switch 1 and switch 2, and once I'm done with that, I should be able to do the ping. I'll also show you some verification commands to see what the trunk is, or whether the trunk is up and what VLANs are getting forwarded or not. So to do this, switch 1, my trunk is E00. If I type it in correctly, oh sorry, gig 00. Switch port, trunk, encapsulation, .1Q, switch port, mode, trunk. All right, and I'll do the same thing on switch 2, interface, gig 00, switch port, trunk, encapsulation, .1Q, switch port, mode, trunk. Done. Once I create the trunk, This is something that you need to be aware of because I haven't mentioned it yet. Once I create the trunk between the two switches, by default, the trunk allows you the ability to carry traffic for any VLAN that is on both switches. So if I have 10 and 20 over here, I am going to carry the traffic for all VLANs across the trunk. There's no restriction. But you do have the ability, if you want, let's say I only wanted 10 and 20 to go across, and I wanted to isolate 30, which is another VLAN that I have on, let's say, switch 1, and I don't want the VLAN 30 to cross the trunk. I do have the ability, if I want to go on the trunk and specify I only want certain VLANs to go across. This is done under the interface, the trunk interface, in our case gig 0/0. There is a command called switch port trunk allowed and allowed VLAN, and you specify the VLANs that you want, 10 and 20. All right. If you don't mention that command, by default, all VLANs are allowed to cross over that trunk. All right. And how do I see what is allowed to cross over the trunk? I haven't specified anything. The command for that is show interface trunk. Oops. Spell it correctly. There you go. Allowed VLANs on the trunk 1 through 4096. Right now that are running, that are forwarding are 1, 10, and 20 because that's the only ones that I've created. But allowed capability, if I tomorrow create a new VLAN, it will be allowed to cross over the trunk. All right. So let's say I just want to allow VLANs 1 through 100 to cross over the trunk. How do I do it? I go under the interface, switch port trunk allowed VLAN 1 through 100. So I'm now restricting only the first 100 VLANs to go across. Good. Switch 2. I would do the same thing. Switch port trunk allowed VLAN 1 through 100. Show interface trunk. And now you'll see that it's only allowing VLANs 1 through 100, and this is allowed. Now, one more thing that I want to bring over here to your attention is, let's say tomorrow you said, no, I want 110. So I need another 101 through 10 allowed. I cannot do this. If I do this, switch port trunk allowed VLAN, I already have 1 through 100. If I do 101 through 110, I'm overriding the previous command. So if I do a show interface trunk, it no longer has 1 through 100 because it overwrote the older command. So if I want to add, the way I would do it is switch port trunk allowed VLAN add. The keyword is add. And then I can specify 1 through 100. All right, no spaces, it's space sensitive. So now it should have the ability to cross all the way to 110 when they're created. See, 1 through 110. Similarly over here, if I wanted to do this, I have 1 through 100, switch port trunk allowed VLAN add 101 to 110. So I'm adding to that. If you don't put the keyword add, it overrides the VLANs that are allowed. Good so far? So now if you take a look at this, I do have my trunk created, my ports are assigned, the two switches are now a single switch fabric. So logically speaking, although you see two physical switches, they're treated as a single switch fabric. Their management domain, you need to manage switch 1 separately, switch 2 separately, but from a data forwarding plane, it is one switch fabric. This is what I call a switch fabric. All right. Now at this point, PC1 should be able to ping PC2, PC2 should be able to ping PC4. Let's go ahead and take a look. The IP addresses for the devices are right over here. For PC1, 1.51 on the one network, 1.53 on the one network, PC2, 2.52 on the two network, 2.54 on the two network. So let's go ahead and take a look at if that works. I have my PCs over here. I'll start with PC1 over here. Take a look. 1.151 or 1.51 is the address. All right. This is my address. I should be able to ping 192.168.1.53. Notice it's pinging, but I cannot ping 2.52, which is your PC2, which is in VLAN 20. I don't have a default gateway configured. But if I go to PC2, which is this guy over here, 2.52, I will not be able to ping 192.168.1.51. You guys can see that because I don't have a default gateway over here. But I should be able to ping 2.54, which is in the same VLAN, same subnet. Although it's across what? It is across what? Two different switches. So although I'm on two different switches, logically speaking, now I'm in a single network, single layer 3 network, so I can communicate to each other. And that's your ping capability. Let's do the same thing for the other. Actually, this I did. PC1 ping PC3, 2 ping 4. So that is communicating. So that test has been validated for me. So right now, what I pinged was PC1 over here pinged this guy over here, and PC2 pinged this guy over here. As I said, logically speaking, the way the networks are right now, I have the 192.168.1.0 network, and I have a separate network, 192.168.2.0 network, PC1 on it, PC3 on it, these two guys. And then I have PC2, this is one, and PC4 on this logical network, and they are able to ping each other, these guys. All right, now that's done. One last thing over here is VTP. What I want to do with VTP over here is, rather than creating the VLANs on both switches, which I had to do, and I showed you that when I had to create the VLAN, although I created the VLAN, it didn't have the same names. What I want to do is I want to have the management of the VLANs done in such a way that when I create my VLANs, I just create it in one place. I just assign the ports in the other under the other switches. So the creation, deletion of the VLANs, or if you want to make a change to a VLAN, can be done centrally on the server and then push it down to the other servers. So I'm going to set up switch 1 in my example over here as a VTP server. And I'm going to set up switch 2 as a VTP client. All right. I'm going to create a domain. Domain is like your AS number for EIGRP that it needs to match. I'll call it CCNA. I'll create all my VLANs on switch 1. I'll create some example VLANs and propagate them to the other switches, which is, in my case, just switch 2. So how do I go about doing it? What are the commands that are required to set this up? I'll go to switch 1, which is this guy over here. I'll set my mode, VTP mode server. All right. By default, it is VTP server. The mode of switch is a VTP server, but the domains are not set. So I'm going to match the domain over here, VTP domain CCNA. It was null. Now it changed to CCNA. Now over here, I'm going to create VLAN 10, 20, and 30. Let's call VLAN 30 name blue. So I created that on switch 1. On the other guy, sorry, not over here, on the other guy, which is switch 2, I'm going to make this into a client. And my VTP domain is also going to be CCNA. All right. Now, if I take a look at my VLANs over here, I have VLAN 10, 20, 30 created for me already. If I go now need to create a new VLAN, I can create VLAN 40 over here, name purple. As soon as I do that, switch 2 will automatically have that VLAN as well. Give it some time. Oh yeah, I need to exit here so that it creates it completely. So as soon as I do that, it should propagate over here. That's it. If I want to assign ports to VLAN 40 or 30, I still need to go to switch 2 to assign the ports. So for example, let's say I wanted to assign port 1/1 to let's say green, not green, to blue. All right. Although I created VLAN 30 on switch 1 and it got propagated, I still need to do this over here. As an example, switch port mode access. So the management of the actual switch is still done on that, or the port assignment is still done over here. So show VLAN over here should show me that there's a port in VLAN 30 as well. So that part is still done on the individual switches. The only thing that I'm gaining by doing the VTP setup is once I set it up, whatever VLANs I create on the server will propagate to all my clients. So configure a VTP domain called CCNI in both switches. We did that. Switch 1 has a VTP server. Switch 2 has a VTP client. Configure 10, 20, 30 on switch 1. I also created a 40. They should be created on switch 2 automatically. I showed you that. Show VLAN to verify it. Everything done. So what I've accomplished over here, guys, is I've set up a switch fabric with multiple switches, with multiple VLANs, and allowed them to communicate to each other over the trunk. So we also saw how to assign, how to create a trunk port between the switches, how to specify what VLANs are allowed to cross over. By default, all VLANs are allowed by default, all VLANs allowed by default. All right, we did that. We saw how to assign ports to a particular VLAN, the access ports. We saw how to create the VLANs with and without VTP. This is where your switching journey starts. This is your basic switching. Now what we're going to do is we're going to take a look at how to connect these VLANs to each other. So right now I have two isolated VLANs. These guys now, although they can talk within the VLAN, PC1 can talk to PC3, VLAN 10. PC2 can talk to PC4, VLAN 20. They cannot talk to each other, and that's where inter-VLAN routing comes up. That's the next video. Don't miss it. Very important. Hope you guys enjoyed it. Thanks for watching.